In our last discussion, we learned about the geospatial database and the two type of data formats, the raster and vector data models. We also looked into their characteristics and advantages and drawbacks. As you know, that geographical data and spatial information, these data are pertinent to features and resources of the earth. So geographic data are spatial because they are geographically referenced. They are linked to the specific geographic coordinates. These information, they also come up with the descriptive element, which gives us an idea that any specific location, what kind of phenomena is existing there. So that way we can link that spatial location with the attribute information or the descriptive element of that specific location. And the third is the graphical element, which tells us what they look like, where they are found and how they are spatially related to one another. So these quality of spatial information we want to represent into our spatial analysis. And for that we use raster and vector data format. So for that we want spatial information, and for that we capture these information through different sources, which we are calling it as the spatial data capture. You all would agree with me that the functionality of spatial information science relies on the quality of data available. Why? Because this we have seen in our previous slide that these spatial information carries many information, or these spatial location we are linking it with many other informations in the form of attribute information, in the form of graphical information, which gives us an idea as to how and why that location is important in the context of the phenomena which we are trying to represent. The advantage and relevance of spatial data is its ability to integrate data from different sources and integrate them and analyze them. That is what the functional ability of the spatial information science. So the true value of GIS and SIS is the proper tool to collect spatial data and integrate them with available attribute data. That's what the basic idea of spatial information science. And for that, as we have said, that it can be in the form of vector format, where we will have point line and area in the form of specific coordinates, or the raster data where we would be using the grid. They are systematically organized cells. So, but the important fact is that we need to import the spatial data or the attribute data, which will be ultimately linked to spatial locations. This is where I would say that is how we model the real world data into GIS or spatial information science. So here the representation flow shows how spatial data, from where the ground realities we draw and the features and objects of our interest can be picked out. First, we georeference them to project them on a map, add attribute information to that specific location, and finally present them in spatial data format, either raster or vector, or in the form which would be ultimately be in the form of point, line and area entity. So what we do, we visualize the ground realities, and depending on our perspective, we draw out certain features. These features we convert them into objects, entities, and then attribute information is added to it, and that way finally the representation come in the form of point, line and area entities. I would say this way the information is being integrated. This way the spatial data integrates different layers. Layers means attribute informations associated with any specific location. So here the latitude and longitudes are depicted. The same area, many attribute information is being integrated in spatial information science, and thus it may also be said as integrating information technique. If you see here, the same geographic coordinates with specific latitude and longitude or xy coordinates, there can be word boundary, it may be a vector in the vector format, there can be roads, they might be a line entity, word boundaries may be the polygon entity, railway track would be another line entity, commercial center would be the point entity, and industrial units would be an area entity. So you see, all these different kind of entities, it can be point, line and area, they all have been integrated in one spatial information science, where we are linking them, all these information, whether it is point, whether it is line or an area or polygon entity, everything, every entity is being linked to specific spatial location, which we are saying, which we are using for spatial information science. And the bottom line is that this science, this technique, this method is the information extraction system. Now we look into the possible methods to draw spatial information from different data sources. We all know that in modern day the data can be drawn from different sources. We have discussed in our previous discussions and talks that there are n number of sources which we can use for spatial information, but some of them, they have been discussed here, but just I want to say that there are different ways to bring spatial information into the spatial information science system. They come in different formats, and all these formats, they need to be linked with geographic coordinates, and that way we can draw it into the spatial information. So as I am saying, the sources are enormous. There are n number of sources which are available, which can be possible source of information for source of spatial information. But how we can incorporate it, some of the examples I am trying to show you in this particular slide. As you see that the data sources are greatly varied. Some of them I am trying to portray here. For example, there can be some data like census data, it can come in tabular data. So it's a data which comes in digits, and these digits, when they are linked with spatial location, it becomes spatial information. Another can be the map data. For example, any political map, political boundary of any state or tehsil or a district, or even for any nation, and then we incorporate any attribute information, add any attribute information to that makes the spatial information. So here we are using the analog mode of incorporating map data or picture or image data into the spatial information. This can be done through digitizing or scanning of maps. So digitizing, using the on-screen digitizing or the digitizing tablet, we can incorporate it into the spatial information. I have said that aerial photograph and satellite imageries they are being used greatly into the spatial information. Again, they can be incorporated using digitizing and scanning. It can be land use map, water body, anything about for the aerial photograph. The same is for the satellite images also. The satellite images, very interestingly, they are in digital format. So from the source, we can digitally transfer also to our spatial information, because our spatial information is also in digital format. So the aerial photograph, it is in analog form, so there you need to digitize or scan it. Whereas satellite images which are in digital format, that we can incorporate directly through digital file transfer. The same is with the tabular data which comes into digital format. Now in modern days census data, they come in digital format. So again I would say that it is very easy to transfer it in digital format into the spatial information. The only exercise is left to bring into the spatial information science is just to incorporate, just to relate it, link it with the spatial information. So I'm just trying to portray that what are the possible sources of spatial information for us. So GIS can contain a wide variety of geographic data types originating from many diverse sources. It can be divided into primary geographic data or secondary sources of data. Primary geographic data sources are captured specifically for use in spatial information science by direct measurement. There are many ways, you all know that how the primary information is collected. So using the same method, we can incorporate the primary information into our spatial information system, and they are known as the primary geographic data. The secondary sources are those which are already existing and need to be reused for our study. So all kinds of digital and analog format of spatial information can be the good example of it. I can say the satellite images would be a good example of secondary sources, or any analog maps, they would be a good sources of secondary sources. So depending on the format and characteristic of digital data, considerable reformatting and restructuring may be required prior to the importing of these geographic data. Now here lies some important steps and measures which we need to take. Otherwise, we may have some kind of data errors in our system which will come with from the source itself. So what is the objective here is that, my objective here is that to sensitize you that you see what is happening. We are drawing data from other sources into our system to use it and to analyze it for our benefit. But if when drawing the data, if it comes with some error, or the way, the procedure through which we are drawing the data, bringing the data into our system, if there is some kind of discrepancy and it comes with some kind of flaws and errors, then our analysis from the very beginning will contain some kind of error. So we need to be a little cautious here when we are drawing data from other sources, different sources. So now we would be focusing on data editing. So the spatial data, as I am saying, they are very complex, and thus at every stage we need to be very careful. Otherwise many errors will come, and these errors will aggravate when we would be processing it, when we would be analyzing it. They would be further enlarged. These errors would result into more errors into the analysis and processing when we will be using the erroneous data into it. So the process of data encoding, which I am saying that bringing the spatial information for our analysis, this process of data encoding is very complex and need to be an error free. But I must say here that data input which is error free is very difficult, because when we are bringing different formats of data into our spatial information, there is bound to happen, there is bound to have some errors. We need to be cautious. We know as to why and how these errors are coming. So we need to rectify it firstly, then we proceed for the processing of that information. So error might come with the transfer of data, but we need to be careful when we are importing it, and at the beginning itself of our analysis we need to process the errors so that minimal error remains in our spatial information which are being processed for our analysis. So here if you see data editing, there are many errors which are derived from original sources or also during the encoding processes, and there may be errors in coordinate data or inaccuracy in the attribute data, so here you can understand that there can be the data related with the location of specific phenomena, and another way of inaccuracy would be when the location is added with attribute information. So there may be inaccuracies in the attribute information. So both way the error may come into our analysis. So it is better to intercept errors at the beginning itself, because this will contaminate the database, and it will propagate the errors will enlarge as we move further while processing the spatial information. And this process of cleaning and is known as can be said as the data editing, and this is one very crucial point of spatial information science when we are using data from different sources. So data editing includes firstly to detect the errors, and when we know as to in which format the original data is existing and what is the process of bringing those data into spatial information, so we would be aware of the possible errors which may come into our system. So first is to be careful about the errors, detect those errors, detect the possible errors which might come, correct the errors at the beginning itself. Then we need to reproject it for our benefit, for our analysis. If required, we need to transform the information also. If required, we need to generalize this information. And if spatially, if there is any kind of error remains, then edge matching and rubber sheeting, which we will be discussing in detail later on, but that can also be done for data editing. So data editing is done when errors incur during input data. In this case, we need to check. Now here we are looking the errors which are coming when we are bringing the data from different sources into our system. So this is the errors related with input data. So errors may appear in the source data itself. So that needs to be checked. Errors introduced during the encoding, as I am saying again and again that in modern day there are different type of data formats which are available. So when they are in different formats and we are bringing it into spatial information in digital format, there is possibility of incurring some kind of errors into it. So during encoding, if we are aware that how these errors may come, so we need to rectify it at the beginning itself. And another kind of errors may come when we will be data transferring or we are data conversion is taking place. For example, you see, if we are using say satellite imagery and we are using vector format of data, so when we would be converting the digital data into vector format, there would be some errors and these errors need to be rectified. So that way I am saying that when we are using the data, while we are transferring or converting it, we know as to what are the possible errors which may happen, and we need to edit it, we need to clean it, we need to rectify it at the beginning itself so that minimal errors remain in our analysis and our analysis would be more perfect and more effective. Now, another kind of data editing is required when errors incur source data. So errors in source data may be difficult to identify. For example, there may be subtle errors in paper map source used for digitizing because of the methods used by particular surveyors. So the original data, if it has some error, that is very difficult to remove. But if you are aware of it, then we can rectify it so that the errors may not come there. Then during encoding also there may be some kind of errors may come. This can be, for example, if we are using keyboard encoding, it is very easy that the operator by fault may be making some typing mistake, so that you need to be very cautious about it. Or while we are digitizing, either online digitizing or on the tablet mode digitizing, if we are not very careful, then a wrong line, wrong point or wrong polygon is digitized. Or while digitizing, if we are not careful, then the perimeter or the area may be a little not very accurate. Then these errors, these will magnify the errors into even more larger errors. Then if we are scanning the map, the folds and stains, they may be coming along with the scanning process, and when we would be converting it into spatial information, again some kind of errors will come. So my point here is that while encoding also there might be some error. Earlier we said that if there are errors in the source information, or if we are encoding it, transferring the data into spatial information, there also errors may come. So error can also occur during data transfer or conversion of data, as I have mentioned earlier also. So during data transfer or conversion of data, different formats are required by different packages, and this may lead to loss of data also. You recall we mentioned about the raster data conversion, and there only on the basis of the grid cells there might be some errors may come. So this is where I would say we need to be a little cautious. Again, another kind of error during transfer and conversion may be errors in attribute data. They are easy to spot and may be identified using manual comparison with the original data. But there again we need to be cautious. So to summarize, errors in spatial data are often more difficult to identify and correct than errors in attribute data. So this is a very significant point which I am making here, that the spatial data are very difficult, whereas errors in attribute data, it is easier to correct. So these errors take many forms depending on the data model being used. So we have discussed about vector format and raster format. So both these data, they have different ways of incorporating the errors into the spatial information, and also the method of data capture. All of them, they can bring in some kind of errors into our spatial information. For that we need to be very cautious about it. All in all, I would say that in modern day spatial information packages provide editing tools for the identification and removal of errors in data, and we would be discussing it, and we would be also practicing about it in our coming discussions, and you would be aware as to how we can rectify all these spatial informations. Corrections can be made interactively also by the operator on screen, or automatically also by the softwares itself. There are many operations which we can perform in many softwares, which automatically they can clear and rectify some of the errors which comes into the spatial information while we are transferring, while we are drawing data from different sources. These are some examples of spatial errors. If you can see here, although we would be dealing in detail later on, but if you can see here, for example, if you are digitizing and you are not completing the polygon over here, so there the polygon would remain as the open-ended. This will be one kind of error. I mentioned that if you are digitizing and if you are not careful, a duplicate polygon, unlabeled polygon may come up. And if you are digitizing, then if instead of two lines come and these lines are overlapping and intersecting each other, then again this may come into error. And while you are digitizing, if you are not careful, then a loop may come. So this will result into you are drawing a line feature, but here you have created a polygon. So that way this is this is one kind of error. Then there is this line should end over here, but it goes beyond the boundary of the polygon. So this is known as the overshoot. This is also one kind of error. Another can be the line feature which is having a dangling node. It has to be merged with somewhere, it has to finish somewhere, it has to complete its path somewhere. So that way it is known as the dangling node. And while digitizing, if there is this kind of error comes because of some errors, it will be known as the spike, and you might have some point while digitizing, if by error if you click within the polygon, one point may come up automatically, and these are the duplicate label points which will come, where you might not be assigning any property, any attribute information to them. So that way they would be consuming some consuming some space in the system, which is useless. Now I said that in modern day we have the spatial information softwares, they have built-in error removal programs. So what they would do when this kind of situation will come, they will, when you would be finalizing your digitization and bringing it into the spatial information, they would highlight these errors, and you would be automatically known to that this polygon needs to be closed, there is pseudo nodes are existing, there is unlabeled polygon, so you can rectify these errors then and there. So that is what the advantage of digital technology in modern day spatial information science, that these softwares using the digital technology, they have inbuilt systems, inbuilt programs which point us about all these errors which we have pointed out, which can be rectified very effectively and easily.